And so you can imagine that it's a very difficult process to control because it's all happening in the cell. And so we know that the 3D structure of the protein affects it. So if the enzymes and the sugar monomers can actually get access to the protein, the availability of the enzymes, which enzymes are present, where they are, as well as how long the protein spends in the cell, and then the sugar nucleotide donors, those are the sugar monomers of the carbohydrate chain. Now, we can't directly control these intracellular properties, but we do know that you can indirectly manipulate them via the culture conditions of the bioreactor that you're cultivating these cells. And so there's been lots of studies looking at how these culture conditions affect the glycosylation pattern. This is a lot of words, but basically we know that the nutrients, glucose and glutamine, have an important role in determining what glycosylation pattern is formed. The ammonia accumulation, pH, temperature, the dissolved oxygen content, as well as the rate of agitation, so how fast you're stirring the bioreactor. So we know that all of these culture conditions play an important role in glycosylation. But if you were to look at what a conventional bioreactor is able to do right now, it's really limited to dissolved oxygen control, pH control, temperature, and agitation. So you can precisely control all of these levels in the bioreactor. But we said that glucose and glutamine play an important role. And so unfortunately, right now there really isn't any online nutrient control available. We can't monitor any of the other metabolites like our ammonia, lactate, other things that we know that are affecting the glycosylation. And then we certainly, if we can't do these things, we certainly can't control the glycosylation pattern. Yes?
What exactly do you mean by an online nutrient control?
So what that means is that, so we want our glucose concentration to be at 5 grams per liter in our bioreactor. And we want it to maintain at 5 grams per liter throughout the whole bioreactor run. Since we don't have online nutrient control, we can't actually precisely maintain what that concentration is.
Quick comment there. I thought early on we might have a small problem there.
Yep.
When she said offline before, offline means they produce the product, then pull a sample, go off someplace else and test it, and then come back and say whether it's any good or not. Not the best setup. An online control would be, we're making it now, we can sample right while we're making it, test it, and then adjust our process to fix it if it needs fixed.
Right.
That's the difference between offline and online.
Right. So.
Right? So you have no time lags. You don't make a bad batch. You fix it while you're making it so it doesn't get bad. Okay.
Do you want to say something?
Yeah, I was going to say it's kind of like it's like football. If like two football teams played each other without their coaches, that's offline. But if you have a coach there, he's able to manage them during the game. Does that make any sense, or is that too outlandish? Okay.
We don't do sports.
Yeah, I know. maybe that's just me. Yeah. Sorry.
All right. All right. So that's the state of the art for bioreactors before I started with my research. So what my project goal is to establish the foundation for effective online real-time controlled glycosylation patterns in monoclonal antibodies produced with Chinese hamster ovary cells. Chinese hamster ovary cells, they're basically just the workhorse for the biopharmaceutical industry. It's a specific type of cell, not really all that important for today. All right, and so what do I mean by glycosylation control? Well, when you produce a batch of protein, you actually get a distribution of glycosylation patterns. That means that you get a bunch of different patterns of your sugars, and you get various quantities of each of these patterns. And so this is a liquid chromatography profile, where liquid chromatography basically is able to separate which carbohydrate it's able to separate the different carbohydrates that we're seeing, and we can actually quantify how much of each carbohydrate that we're actually carbohydrate pattern that we're getting. And so basically what we want to do is, initially we want to be able to just reproduce what this distribution is. So from batch to batch, we want to be able to get this same exact glycan pattern distribution. And then once we're able to actually reproduce it, then we want to drive it to certain glycan patterns that we actually want. So, how are we actually planning on doing this? Well, my group is a controls group. Now, you probably haven't heard of controls before. Process controls, guys, you know what that is? No? Okay. So what process controls is basically, it's the theory behind, so you want to keep your pH at, say, a pH 7, which is a neutral pH. There's control theory in order how you actually maintain that specific set point. So
it's just the offline online thing
it's the
again.
offline online thing. But there's a lot of like theory behind how you actually go about maintaining that specific set point. And my talk is actually going to be a little bit going into that. So it might be a little bit. If you have any questions, just let me know. So anyway, so we've established that. So what we have right now is we can establish set points for our dissolved oxygen, pH, temperature, and agitation. We can precisely control those in our bioreactor, and we'll get out some kind of glycosylation pattern. But we've established that nutrients such as glucose and glutamine play an important role. So what we'd really like to do is be able to have online nutrient control. So how are we going to do that? Well, if we could have online nutrient measurements, and then a controller specifically for our glucose and glutamine, we can precisely control those levels in our bioreactor, and then we'll have some, one more level of control for glycosylation. And this is what's known as base regulatory control. Now, what base regulatory control is basically, it's just it's being able to control the process variables that you know to affect a certain response. So in this case, the glycosylation is our response that we're interested in controlling. The various process variables that we can manipulate in order to control our response are our glucose, glutamine, our pH, temperature, and agitation rate. All right, so if we add this second feedback control loop, we're able to control our glucose and our glutamine. But this doesn't actually control our glycosylation pattern. We can't actually manipulate it to where we want it to go. We can just establish set points. To actually control it online, we need to have another feedback loop where we have glycosylation assay measurements and a controller specifically for our glycosylation pattern. Now, the problem with these glycosylation assay measurements, so there are analyzers that you can actually measure these nutrients fairly quickly, but these glycosylation assay measurements, they have to be done offline. So this is where you take a sample, you do some analysis in a lab, down the hall. It takes a few days, and then you get some measurements, you get some information, and then so you can imagine that if you're only getting this every 2 days or so, if you try to feed this into a controller, it's very hard to do feedback control on that because you have such a long delay between your measurement and what you're trying to do to your process.
How long does the batch usually last?
So the batch usually lasts about a week. So if it takes you 2 days to do your sample, you've already gone, well into your batch that you're doing. So
it would be analogous to driving down the turnpike and controlling your speed by timing the distance between the road markers. If you're going too fast, you got to wait till you drive a mile, and it's got, oh, it was only 57 seconds. I better slow down.
yeah.
Right? You want to be going 60, so it should take 60 seconds. So and this control loop, by the way, is very analogous to cruise control.
Mm-hmm.
She's trying to set up cruise control for this process.
Yes.
Right?
That's exactly what I'm trying to do.
She's trying to get it to measure something, say, oh, too much, back off. Oh, not enough, add it on. But apparently your problem is, whereas your car can measure your speed,
Right.
we don't have a way to measure glycosylation.
Right. So what we're going to do is we are going to implement